Alright, sige. This is the second and third open domain methods. For root finding methods, we have Newton-Rhapson method and secant method. Let's discuss each. First is the Newton-Rhapson method. Okay, fun fact. This is the method na ginagamit ng kalye nyo pag nagsisolve or pinapa-shift solve nyo siya ng roots ng single variable equations. Okay, looking at the visualization dito, yung graph, uh, nag-work yung method na to by drawing a tangent line. Okay? So, may tangent line ka sa function at your initial guess x sub 0. For example, your initial guess is x sub 0, tas yung point na yun dun sa graph is this one. You find or you'll be asked to get the uh, slope of the tangent line sa point na yan. Okay, so ito yun. Okay? And then, yung x-intercept ng tangent line na yan dun. Okay, yung x-intercept niya would be your next guess. Okay, yung improved guess, yung x sub 1. Okay? So, kung saan ma-intersect ng tangent line yung x-axis, yun yung next guess mo. Okay? So, looking at this visualization, paano natin kukunin yung formula ng x sub 1? We have here f of x sub 0, di ba? Itong length na to, yung height. Kasi this one, ito yun eh. Okay? yung point na to, ang coordinates niya are x sub 0 and then f of x sub 0. So, itong length na to, yung height is function value nung, uh, nung function natin sa x sub 0. Okay, so ito yung y, ito yung rise, ito yung run. Tama? So, rise over run, f of x sub 0 over yung x sub 0 minus x sub 1. Yun yung formula para sa slope ng line na to. Okay, so that's f of x sub 0 minus yung difference ng x sub 0 and x sub 1. Okay. So, ano natin? What do you call this? Isolate natin yung x sub 1. So, lipat natin sa kabila. Lipat natin to sa denominator. Have x sub 0 equals x sub 0 minus x sub 1 is now equal to f of x sub 0 over f prime of x sub 0. Okay. Lipat natin yung x sub 1 sa kabila. Then lipat natin to sa kabila. We'll be left with this equation. X sub 1 equals x sub 0 minus f of x sub 0 over f prime of x sub 0. Again, saan nang galing ito? Galing lang to sa slope ng line na to, which is yung main idea ng Newton-Rhapson method. Yung slope ng line na yan is yung first derivative ng function natin at this point. Okay? Equal yan sa rise over run. So, f of x sub 0 over x sub 0 minus x sub 1. Okay, and then isolate yung x sub 1, makakuha mo x sub 0 minus f of x sub 0 over f prime of x sub 0. Okay? So, thinking na ito yung improved guess and this is your initial guess or your current guess, we have x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. So, ito na yung magiging formula natin or yung magiging algorithm natin for Newton-Rhapson method. Okay? Just for you to understand, mas magets yung itsura ng Newton-Rhapson method. Yung ginagawa niya, we have here the function, tapos may initial guess ka. Okay? Then, ang bilis eh. Sorry. Okay, so may initial guess, kukunin niyo yung function value, then slope niya, kung saan nag-intersect, kukunin niyo ulit yung slope, kung saan i-intersect next, kukunin niyo ulit yung function value niya sa point na yun, and so on and so forth. Ulitin ko. May initial guess ka, kukunin mo yung value ng function, no? Doon. Okay? Tapos, drawing ka ng tangent line dun sa point na yon. Okay? Tapos kung ano kung saan mag-intersect yung tangent line na yun yung next guess mo. Okay? And then kunin mo ulit yung value ng function mo dyan sa point na yan. And then draw another tangent line. Layo. So, dyan daw yung x sub 3. So, yun yung next guess mo. Okay, and then get the function value at that point. And then slope ulit. Okay, so dyan yung x sub 4. Dyan nag-intersect yung slope. And then, get the function value. Okay, tapos slope na naman and so on and so forth. As you can see, lumalapit siya dito sa point na ito kung saan na yung solution natin. Okay. Diba? Parang mas mabilis siya mag-converge compared dun sa fixed point iteration. Right? So, para lang makita yung algorithm, ang nangyayari dito, kinocompute niya yung solution natin for the f of x equals 0 using yung initial approximation natin. Okay, tapos kinukuha natin yung derivative. Okay, so isa-isahin natin to. Ang input natin is yung function value. Okay, syempre may initial value ka kasi. So alam mo yung function value at that point. And syempre, since may function ka, tapos kukunin mo yung first derivative, substitute mo rin dun yung initial guess mo, meron ka na rin first derivative. Okay, dapat given din tayo ng tolerance value for our error para alam natin kung kailan natin titigil ng iteration or yung maximum number of iterations. Okay, so ang output, ang gusto natin i-output ng program natin is yung solution, approximate solution or message of failure. Okay, so sige. Sa bawat iteration natin, ang nangyayari is kinocompute muna yung first derivative. Okay, alam mo yung first derivative. Okay, and then kung yung derivative na yun is equal to 0, failure agad yun kasi nasa denominator yan. Okay, so hindi pwedeng 0 agad yung slope mo sa start pa lang. Okay, pero kapag hindi naman, pag non-zero naman, isosolve niya na itong equation natin. Okay, solve mo yung function value, solve mo yung value ng first derivative sa point na initial point natin, and then subtract natin yung quotient na yun from the una nating guess. Okay, and so on and so forth. Okay, hanggang sa titigil lang siya kapag yung they call this error, absolute error. Ganun pa rin yung absolute error. Kina-compare niya pa rin yung previous value ng guess natin tsaka yung current value. Baliktad. Current value and yung previous guesses natin. Okay? Pag mas maliit na siya compared dun sa tolerance natin na error, then tapos na. Complete. Kung ano yung value ng current nating guess, siya na yung i-output ng program natin. Okay? Pero kung hindi niya pa rin to na-achieve kahit tapos niya na yung n iterations, ito yung papakita niya. Failure din. Kasi after n iterations, di pa rin siya nag-converge. Okay, so ito yung algorithm niya for Newton-Rhapson. Okay, apply lang natin sa isang example. We have x squared minus 3x plus 1. Ito rin yung example kanina sa fixed point iteration. We're asked to use an initial value of 1. Okay, again, ano important dito? We need to find the first derivative. Okay, pero okay lang, at least yung compared dun sa kanina na fixed point iteration, marami kasing pwedeng possible na g of x. Dito isa lang naman yung derivative ng function mo. Okay. So we have here the first derivative. Ano yung derivative ng x squared minus 3x plus 1? That's 2x minus 3. Okay, so meron ka ng functions for the function mo and yung first derivative. So madali lang gamitin ito kasi ito lang naman yung working equation mo. Okay, starting with the first iteration, gamit ulit tayong table. First iteration mo, initial value is 1. Substitute mo yung 1 dito. I should get 1 minus 3 plus 1, negative 1. Substitute mo rin yung 1 dito. Sorry. So, tama, di ba? Pag sinubstitute ko yung 1 dito, makukuha ko negative 1. Pag sinubstitute ko rin yung 1 dito sa derivative, I get also negative 1. Okay, solving this, I get negative 1 over negative 1. Tapos yung first value natin is 1. So, 1 minus 1. So, 0. 0 yung next guess natin. As you can see here. Okay. Next. Substitute mo yung 0 both here and here. I get 1 and -3. Okay, and then substitute natin yan each here. I have 1 and 3, -3. Okay, tapos ito yung 0. 0 minus -1/3, I get 1/3. So, 0.33333 yan. Okay, so yung next guess mo. Again, substitute here, lagay mo dyan, then use this equation, you get the next guess. Pero no, tuloy-tuloy lang din. Okay, and yung absolute error dito is yung difference no previous and yung current guess. Absolute difference. So sa case na to 1, and sa case na to 0.333, and then ito 0.04762, and so on and so forth. As you can see, pang limang iteration pa lang, halos 0 na. Okay, parang kung ang tolerance mo is 0.000001, okay na ito. Hinto ka na sa 5th iteration, and you arrive at this approximation which is very close to the real root na smaller, yung 0.381966. Okay, so that's the Newton-Rhapson method. You have an initial guess, and then you have to solve for the first derivative. Okay, yun lang. So, hindi natin kailangan ng maraming types ng g prime of x, ay g prime ng g of x, di ba? Unlike Newton, ay ng fixed point iteration. Kailangan lang dito is different roots, different initial values or initial guesses to arrive at different roots. Sa case na to, kapag ginamit ko yung initial guess na 1, makukuha mo is yung smaller root. Okay? Pag nagtry kayo ng ibang initial guess, pwede niyo kuha yung other larger root na 2 point something. Right? Sir, what if mahirap kunin yung derivative ng function? Diyan naman papasok yung next, yung last nating open domain method, yung secant method. Okay? Again, kung naalala nyo yung Newton-Rhapson, gumagamit ng derivative. So, kung mahirap isolve yung derivative na yan, anong gagawin natin? Pwede natin i-apply yung natutunan natin sa Module 1. Tama? We'll be using the difference quotient. Okay? Kung naalala nyo, difference quotient is just the difference between the function values and yung difference between the x. Okay? Pero hindi ganyan yung form dun sa natin sa previous module natin kasi over h yun eh. Pero same lang yan. Diba? F of x plus h saka f of x. Same lang. So, difference quotient lang. So, instead na f prime of x sub of x sub n yung i-substitute natin dito, itong buong to yung ilalagay natin sa denominator. Okay? And then, kunin lang natin yung tawag dito, reciprocal niya para pwede natin ilabas dito. Okay? So, we have yung next term or yung next guess natin is yung previous guess minus itong numerator times yung reciprocal nitong denominator, which is x sub n minus x sub n minus 1 over f of x sub n minus f of x sub n minus 1. Okay? So, dito, hindi mo na kailangan isolve yung first derivative ng function. Okay, di ba? Pero ang kailangan mo dito is meron kang 2 points. May dalawa kang initial points. Okay, dalawang initial guesses. So, we have x sub n saka x sub n minus 1. Right? So, balikan natin. Okay? Secant yung tawag dito kasi meron tayong dalawang points na nag-intersect dito sa curve. Okay? Kukonect natin yan. And then, kung saan ma-intersect yung x-axis, yun yung next nating guess. Okay? So, itong dalawa naman yung ito yung next guess. And then, solve naman natin yung function value dyan. So, yung previous nating x sub n, siya na ngayon maging x sub n minus 1. Okay, tapos yung current natin na x sub n plus 1 maging x sub n. Okay, tapos kukonect ulit yan. Okay, tapos ito yung intersection ng secant dun sa x-axis. And so on and so forth. So, similar lang din siya sa Newton-Rhapson, pero this time, dalawa na yung points natin. Secant na. Dalawa na yung initial guesses natin. Right? So, for you to visualize, ito siya. Okay, so Yung latest na dalawang points yung gagamitin for the next iteration. Okay, pero ang important is we have two initial guesses, x sub n tsaka x sub n minus 1. Okay? So, similar lang talaga sa Newton-Rhapson. Ang maganda lang, walang evaluation ng derivatives, pero may two starting guesses. Let's apply this to this example. We have a function na trigonometric f of x equals x minus 2 sine x. We're asked to use two initial values, x sub 0 na 2 and x sub 1 equal to 1.9. Just a reminder, kapag nagko-code ka or kapag sa Excel ka, naka-regions, okay? Naka-regions yung equation, yung mga yung mga ano to, angles natin. Okay, pag may trigonometric function. So, gamit rin tayong table. First, ang first nating ano nga ba ulit yung formula dito? We have x sub n plus 1 is equal to x sub n minus f of x sub n times x sub n minus x sub n minus 1 over f of x sub n minus f of x sub n minus 1. Okay, so kung meron tayong dalawang initial values na 2 and 1.9, substitute natin yung 2 na yan sa function. Substitute din natin yung 1.9 sa function. Okay, pag 2 yung sinubstitute natin, if you try sa calculator na naka-regions, we have here 2 minus 2 sine 2. You get 0.18141. Tama. Okay, pero pag 1.9 naman sinubstitute mo, 1.9 minus 1.9 times sine of 1.9, you get 0.00740. Okay. Hindi pala. 1.9 minus 2 times sine 1.9. Sorry. Okay, so tama. 0.0074. Okay. So, ano tong absolute error na to? Yan pa rin yung difference ng dalawang guesses natin. So, sa case na to, 2 minus 1.9, that's 0.1. Okay. And then, substitute natin itong lahat ng to. Let's substitute lahat ng values na to. Itong apat na ito. Dito. Okay, so we have x sub n is 1.9 minus function value niya doon, which is 0.0074 times difference no guesses, which is 0.1. Negative pala. Kasi 1.9 minus 2. Negative 0.1 over 0.00740 minus 0.18141. So you get 1.89575. Tama. So, kung ano man yung result ng equation natin, ito na yun. Siya na yung current guess natin. And then yung previous guess is yung current guess ng last iteration. Okay, and then itong absolute error na to is yung difference nitong dalawa. So, 1.9 minus 1.89575, I get 0.00425. Okay? And then you just repeat the process. Solve mo yung function value dito sa 1.9. Ito rin, same lang naman yan. So, basically, ito nang isa-substitute mo sa function, makuha mo to. And then, gamitin tong apat na to solve for this one. Okay? Tapos, lipat mo itong dalawa na to dito. Ulit, transfer mo itong dalawang to sa next iteration. Okay. Then, kunin mo yung function value sa point na to. You get this. And error is ito, difference itong dalawa. As you can see, sa pagdating parang pang-apat na iteration, maliit na yung error. So, kung ang tolerance mo is 0.00001, okay na yung fourth iteration. Nakuha mo na yung root natin, which is 1.89549. Okay, so that's all for the open domain methods. For our next content, I will be talking about the closed domain methods, bisection method, and regular fallacy method. For now, bye muna.